So today I'm going to talk about the modeling and designing of an atom. First of all, what is modeling and designing of an atom? The modeling and designing of an atom basically mean the position, not portion, the position of an atom in three axes, right? So we're gonna move to second. We're gonna move this. Fine. So first of all, is I'm gonna discuss the scientist here. The first was actually the structure of atom was given by the different scientists, not only by the one scientist. The first was J.J. Thomson. Okay, so second was Rutherford, right? Rutherford. Hmm. Rutherford. Third was Bohr, right? And then quantum. Before quantum, there was one scientist, but I just thought I wanted to write his name here. We're going to discuss later on. Okay, the first of all, we're going to talk about what J.J. Thomas did, right? This was the scientist involved in the discovery of an atom, like the structure of an atom, right? But J.J. Thomson model. Okay, what J.J. Thomson did is that actually the name of his model was raisin pudding model. This is the name of his model, but it was such an hypothetical model. No explanation, no experimentation was given on the basis of, I guess, only hypothesis. Raisin pudding or watermelon, because this was the structure was somehow similar to watermelon, and Thomson model. So there was the name of his model, right? Okay, Thomson. I'm sorry, Thomson model, right? So this was scientists involved in the actually structure of an designing the structure of an atom. So what he did, the Thomson said that the positive charge are uniformly distributed towards positive charges. I'm going to show you a picture as well, that the charges are uniformly distributed distributed distri- distributed distributed in an atom. I'm sorry, in an atom, that positive charges are uniformly distributed in an atom. This was said by the J.J. Thomson. I'm going to show you one picture here. So this was a model of J.J. Thomson. As you guys see, wait, it's right here. As you guys can see, this was a model. These are electrons. As you can see, guys, this is electrons. These are electrons uniformly distributed among the atom, and positive charges are distributed uniformly all over it. Actually, we can also say that atom is a spherical cloud of positive charges. Here is the positive charge, the positive charge, here the positive charge is positive charges, and electrons are embedded like a resin in pudding, right? So we can have example of watermelon. For example, have you seen that seeds in the watermelon? So we can consider that example as well. And the shape is spherical, like Thomson was actually successful explaining the stability of an atom. He said that the atom has positive charge and negative charge, so both are in I can say that in rest, and they possess no energy in sense of kinetic energy or in sense of potential energy. So let's move back to slide. So this was a said by J.J. Thomson, right? J.J. Thomson said this. Okay, so he successfully explained the stability of an atom. He successfully, but he successfully successfully explained the stability of an atom. Stability of an atom. Okay. So I told you why, because it consists of positive and negative charges. So and I'm going to talk about the next scientist here. Was the second scientist was actually Rutherford. Actually, the experimental work started from the Rutherford. He did the first experimental work on the basis for the discovery, actually, the discovery of the atom. So his work was based on experimental method. His work was based on experimental method. What he said that I'm going to show you here. He said atom okay. He said that atom performs spiral motion, right? So he said atom performs spiral motion like this, but it's not true. Otherwise, you know, it can be happen that electron can easily jump in the nucleus and everything would be destroyed. So this model was rejected on this basis that atoms actually do not perform spiral motion, right? So this model was rejected, and then we have other model which was given by the Bohr. Actually, the Bohr was a student of Rutherford, right? Bohr, he was a student of Rutherford. Was a student of Rutherford, right? So what he did, he said the electrons, actually the electrons of the atom electrons of the atoms, negative charges were known, but remember that the J.J. Thomson gave his model before the discovery of proton and nucleus. Proton and nucleus were not known. Positive charges were known, which usually positive and negative charges are neutralized by each other, right? So it was known that for the stability of an atom. So he said electrons perform spiral motion, right? Orbital motion, orbit motion, okay? Orbitization, orbit motion, but these are different between orbit and orbitization. Remember the orbit motion, or we can call it orbitization. So what is orbitization? Let me just remove here. I'm going to leave this all. Orbitization means this is 4 axis: x-axis minus x-axis, y-axis minus y-axis, which means the atom moves in all 4 axes like this. But the theory was rejected later on, just because atoms cannot perform this motion, like the orbital motion. Otherwise they will collide with each other's body and everything would be destroyed, right? So this model was also rejected. But there was one scientist, the scientist came, he was Heisenberg. What he did, he did an experiment. Okay, so he took an atom like this, and electron, you know that the atom is consist of electrons. So what it did is that he passed the high intensity photons, okay? He passed the high intensity photons, and what he observed, that there was no electron he found. And he concluded that he said uncertainty with his atom is not consist of electrons, just because when he passed the high intensity light, the electrons were excited and moved into excited state, and he observed no electron with the help of electron microscope. And when he passed the low intensity light, he also did not observe anything, just because of light. When electron gains light, the electrons become excited and they usually move to higher states. So the model was given by it was actually concluded by Heisenberg. The atom is not consist of electrons, which is known uncertainty, but later on it was rejected as well, right? So I'm going to remove this here. Okay, so this was given by Bohr. But one more quantum atom, like the model was given by quantum saying that let me change the color, more visible to you guys. Okay, so Bohr said that atom perform orbital motion. Atom perform orbital motion. What is orbital motion, or orbit, right? Which means the electron in the atom spins in its fixed position. Yes, it does the move in all the directions, like in all the axes, but it spins. It performs spin motion. It spins in one axis and it's fixed direction. So it was given by quantum. There were no many discoveries made by different scientists, but there was only the overview of the discovery of the structure of an atom given by the different scientists and their ideas, right?